Hello, welcome to Unit 4, Lesson 8 with Professor Blackman on solving quadratic equation. So in this lesson, we're going to be solving quadratic equations by factoring and then using a graphed quadratic equation. We're going to look at and find the x-intercepts. So in order to understand what we're doing with factoring, we have to apply this principle of zero. And the principle of zero states that if a times b equals 0, then a could equal 0, or b could equal 0, or both could equal 0. And then the reverse is also true. If a equals 0 or b equals 0, then a times b will always equal 0. And then right here I have some steps on how to solve. You can go ahead and copy those down to your notes. It's just a great checklist that you can go through as you are solving equations. Let's go ahead and get started. All right, so if you haven't watched my videos on factoring, please go back and watch those. But what we're going to need to do is factor here. So we need two numbers that multiply to give you negative 28, add to give you 3. So x and x, back sign's negative, so one of these is positive, one of these is negative. And that will be 7 and a negative 4. Always check before moving on. X squared, negative 28. Inside 7x, outside is negative 4. 7 minus 4 gives you 3. So now we can apply the zero factor property, which says we can make this a equal to 0 and this b equal to 0. And if either one of those equals 0, then the whole thing equals 0. So subtract 7 from both sides, we get x equals negative 7. Add 4 to both sides, we get x equals 4. And so we get our solution as negative 7 and 4. Now we can always go and check because this is a solution, and we can make sure that the left side equals the right side. So when we go to check, negative 7 squared plus 3 times negative 7 minus 28 should equal 0. 49 minus 21 minus 28 needs to equal 0. 0 does equal 0. So that we check this when x equaled negative 7. We can check when x equals 4. That would be 4 squared plus 3 times 4 minus 28 needs to equal 0. 16 plus 12 minus 28 is equal 0. 16 plus 12 is 28. Minus 28 does in fact give you 0. So both of these work. All right, so here, in order to apply the zero factor, the zero principle rule, we need to zero out one side. So y squared, move that 6y over by subtracting it from both sides. And we get this. So now we need to factor this, which is y minus 3. Y minus 3 equals 0. So now we can apply where each one is set equal to 0. We get y equals 3, and the same thing over here. So our solution is y equals 3. And we can check that, because again, it is a solution to the equation above. So when y equals 3, that's 3 squared plus 9 equals 6 times 3. So that's 9 plus 9 equaling 18. Left side's 18, right side's 18. So that is our solution. All right, let's look at some more examples. All right, again, this one's not in order. So we're going to rewrite it to look like this. I just switch the x squared to 9x. Two numbers that multiply give you 20, add to give you 9 is x plus 4, x plus 5. Set each one of those equal to 0. And then right here, we will subtract 4 from both sides and get x equals negative 4. Subtract 5 from both sides and we get x equals negative 5. So we get a solution as negative 5, negative 4. Now, a lot of people ask why I switch these. Well, -5 is a smaller number, so it's listed first. -4 is a larger number, it's listed second. All right, so this one, we will factor it by using the GCF. You can see that they both contain an x. So I'm going to factor out an x, and then that leaves an x plus 8 equaling 0, and set each of these factors equal to 0. A lot of people will always forget to set the first x equal to 0 and x plus 8 equal to 0. Don't forget to set both factors equal to 0. Subtract 8 from both sides and you get -8. So our solution is x equals -8 and 0. All right, let's look at another example. So in this one, we can see that it is difference of squares. So that's x plus 5, x minus 5. And so now we set each of those factors equal to 0. X plus 5 equals 0. X minus 5 equals 0. Subtract 5 from both sides, we get x equals -5. Add 5 to both sides, we get x equals 5. So we get x equals -5 and 5. Or some people like to write it as x equals plus or minus 5. Either way is acceptable. All right, so we need to zero out one side. So we get z squared minus 144 equals to 0. And again, this one is also difference of squares. So that's z minus 12, z plus 12. Set each of those factors equal to 0. Z minus 12 equals 0. Z plus 12 equals 0. And solve each of those for z. Add 12 to both sides, you get z equals 12. Subtract 12 from both sides, and you get z equals -12. So z equals -12 and 12. All right, let's look at another example. Okay, so here we have a leading coefficient that's not 1. So I showed how to do this with multiple different methods. I'm going to choose to do splitting the middle. So we identify our b as 8, and our a times c is 3 times 4, which is 12. So I need two numbers that multiply to give me multiply to give me 12 and add to give me 8. I will use 6 and 2, which will give me the 8. All right. So now I'm going to split this 8 into 6b and 2b. Bring down everything else. Bring down that 3b squared. Now I'm going to do factoring by grouping and get 3b, leaving a b plus 2 in the middle. Factor out a 2, which will leave me a b plus 2 in the middle. Bring that b plus 2 to the front, and the 3b plus 2 in the second one. And then I set each factor equal to 0. 3b plus 2 equal to 0. And that will give me b equals -2, 3b equals -2, and b equaling -2/3. So our solution is b equals -2 and -2/3. All right, let's go ahead and do it to this one as well. So my plus b in the middle will be 15. And my a times c gives me 9 times 4, which is 36. So I need two factors that multiply to give me 36 and add to give me 15. Those numbers will be 3 and 12, which will add to give me the 15. So I'm going to split 15y into plus 3y plus 12y. Bring down everything else. Bring down what's in front. And now, again, I'm going to do factoring by grouping. So factor out a 3y. That will leave a 3y plus 1. Factor out a 4. That will leave 3y plus 1. Bring my 3y plus 1 to the front. And then I will have a 3y plus 4 in the second one. Set each factor equal to 0. Set the second factor equal to 0. And I get 3y equals, subtract 1, you get negative 1. Divide by 3, and you get negative 1/3. Subtract 4, and we get 3y equals negative 4. Divide by 3, and we get y equals negative 4/3. And so then we have y equals negative 4/3 and negative 1/3 as my solution. All right, let's look at some more examples. Okay, so here we are going to look at finding x-intercepts and solutions. Well, x-intercepts and solutions are the same thing, with the exception of x-intercepts being a coordinate point, but the solution will be that x value. We also will use the terms roots sometimes, and we'll use the term zeros. But these four words all go together. Okay, so if we have x squared minus 4x minus 45 equaling to 0, it looks like it's crossing right there and right there. So it looks like negative 5 and 9. Well, when we factor this, we get x minus 9, x plus 5 equaling to 0. So that's x minus 9 equals 0, x plus 5 equals 0. So that's x equals 9 and x equals negative 5. Because that point right there is negative 5, 0. And that point right there is 9, 0. And so that 9 matches with our x equals 9, and this negative 5 matches with the x equals negative 5. So now we have our x-intercepts and our solutions. All right, let's do it for this one as well. I'm, of course, going to rewrite that as a negative x squared plus 4x plus 32 equaling 0. I'm going to divide out that negative 1. So now we have x squared minus 4x minus 32. Now when we were factoring in previous ones, we'd have to pull that negative 1 out, but since we're solving, we can just divide that negative 1 out. So now I need two numbers that multiply to give me negative 32 and add to give me negative 8. And it looks like that's maybe a negative 4, and that's a positive 8. And so I'm going to use those 4 and 8, but the 8 is negative and the x is the 4 is positive. So then when we set each one equal to 0, we will then get x equals 8 and x equals negative 4. And you can see that that right there is 8, 0. And that point right there is negative 4, 0. All right, let's look at some more examples. All right, so we're going to do the same thing here. We're going to start with that negative x squared minus 3x plus 40 and set that equal to 0. Divide out that negative 1, and we get x squared plus 3x minus 40 equals 0. And two numbers that multiply give you negative 8, negative 40, and add to give you a 3. It looks like one of them is going to be a 5, and maybe that's an 8 over there. So x plus 8, x minus 5. And we can always check x squared. 8 times negative 5 is negative 40. Middle is 8. Outer is negative 5. 8 minus 5 gives you 3. So we get x plus 8, setting each one equal to 0. X minus 5 equals 0. So x equals negative 8 and x equals 5. And you can see right there that that is 5, 0. And this one over here is negative 8, 0. All right, so let's look at another one. We have 3x squared minus 12x equals 0. And these have a GCF. I'm going to factor that 3x out. And that will give me x minus 4 equals 0. 3x equals 0 as one factor. X minus 4 as the other factor. So this, divide both sides by 3, you get 0. Add 4 to both sides, and you get 4. And you can see that, that point right there is at 4, 0. And that one was crossing at the origin. So that's 0, 0. That's all I have for you today. Happy studying.